Hi, this is Rahman Sheikh. Welcome to Fortnightly Railway Transportation Systems podcast. I am the host and railway systems specialist working in this industry for 24 years and counting. This podcast is primarily focused on railway experts who have vast amount of experience and contributed greatly to this amazing industry. This is not a technical seminar but focuses on feel good stories, individual journeys, their success and failures, motivating younger generation to kickstart their career in railways and creating a sense of pride for the railway people who devoted their lives on the most environment friendly public transportation. Our guest for this fortnight is Dr. Andrew Hussey, Director Regional RAMS Asia Pacific at Hitachi. Andrew is an experienced systems and RAMS expert with over 25 years experience in the railway transport and control systems industries, as well as being a technical specialist in the areas of systems, RAM, safety, and software engineering. Andrew also has extensive experience in line management roles, both within project and organizational structures. He has a keen appreciation of the operational and safety criticality of railway signaling systems and of the role he plays in ensuring that those qualities are achieved. Previously, Andrew was employed by Invensys Group in Brisbane as a VNV engineer and then development engineer. Andrew has a strong academic background and worked as a research fellow at the University of Queensland, conducting research and technology transfer to the industry partners in the software and safety domains. Hi, Andrew. Welcome to Railway Transportation Systems Podcast.
Hi, Sheikh. Hi, nice to be here.
Thank you. It's a generic question, but I will change it a bit so that our audience don't get bored. I will start with a question on your career. What attracted you to engineering? Tell us your passions and about your education path, please.
Yeah, I got into engineering through software engineering, but it was a little bit of a convoluted path to get to where I am now. Originally, I started out in a computer science degree, but then spent some time studying law and studying psychology before I realized that really my passion lay with software. And so I got back into software and eventually completed a PhD in software, which was through the Department of Computer Science and Electrical Engineering. And then after that PhD, I started work with a place called the Software Verification Research Centre. It's no longer there anymore, was at the University of Queensland. And these guys introduced me to the work they were doing on safety-related systems for the Defence Department. And that was really my first introduction to the broader field of safety and therefore to systems engineering. But I spent some time working specifically on software when coming back to Australia after spending some time in Sweden. And then with Invensys on SCADA systems, I moved across to work for Ansaldo STS, who were working on railway. And it was then that I really started working on systems engineering projects rather than just software. But, to come back to your question about what really attracted me to the engineering, why I got back into software and then, persisted for so long with systems and RAMs, it's really the variety and the challenges and the opportunity to learn. In engineering, you never really stop learning. And I think that's the thing that keeps me interested in it and attracts me.
You had a great career so far, Andrew. Science and engineering, both are interesting, but science can amuse and fascinate us all. But it is engineering that changes the world. Talking about Hitachi and your job at Hitachi Rail, out of many options available, why did you choose to specialize in rail?
Yeah, well, as we sort of talked previously on this topic, I have to say that really it was rail that found me. That story was that I was working for Invensys, working on SCADA, and I might have stayed working for Invensys developing software if it wasn't that they decided, they being the management at Invensys, decided it might be cheaper to develop that software in India. So they moved offshored the software development to India. So I needed to find a new job. And then my ex-colleagues from the Software Verification Research Centre contacted me and said, why don't you come and work for Ansaldo STS, who were doing these railway projects. So then when I came to Ansaldo STS, that was when, it was my first exposure to rail. And we started working on this project, this ATO project, as it was called in Western Australia, to develop an ATO for Rio Tinto for these big freight trains, which are like 20,000 plus tons in size. And, that's when I got hooked because the hardware and the technologies are so complex and various, and the technical domain, with these big trains is so fascinating. As I said to you previously, I still haven't lost my interest in them now after 17 years of working on this stuff.
Trains, the big freight trains. Trains are fascinating, isn't it? I love them.
They are to us.
Trains have changed the world we live in more than any other single machine from the moment the first locomotive steamed into action. Did you know that? That's why I love anything and everything about railways.
They'll keep changing the world too, Sheikh, that's for sure. But we'll come to that later.
Sure. And now that you are in rail with Hitachi, what's a normal work day at Hitachi Rail entail?
Yeah, a normal workday for me, I guess you mean. Yes. So I've got a team, a pretty big team, which is based in 3 sites, mainly Perth, Brisbane and Taipei. And so I spend a lot of time coordinating with my technical leads in that team, as well as, in fact, with all the guys in the team. I'm a big believer in taking the time to talk to the guys in the team to gather information. Typically, I spend time in the mornings mainly recovering information on the current status. And then depending upon what has come out of that, then I try to process some of those key issues in the afternoon. I mean, obviously, not all issues can be managed in a single day, and there's concerns that go on over weeks or months or even years, of course, in fact. And then, when I come home in the evenings after I've done all the things that all of us need to do, I typically spend some time on reading and professional development and, keeping up with the latest that's happening in the business.
Great. That's a people leader. When you talked about your people and you talked about you listening to your people, I think I more loved that point, because you're creating an environment in which others are able to self-actualize in the process of completing the job. Thank you for doing this.
I'm very, very passionate about that, Sheikh, actually, that point you raised. Yeah.
Yeah, love it. So moving forward, what engineering milestones you have been most proud of whilst working at Hitachi Rail?
Yeah, I was talking to a colleague of mine, Arvind Raj, just this afternoon, and we were talking about reminiscing a little about some of the work that we did on the Banker project. That was an extension of the order hall work that we've done. So we built in the end this ATO system for Rio Tinto, and it's been in operation now for some years. A few years ago, we extended that with what's called the Banker extension, which is a Banker locomotives or locos that are at the back, or could be in the middle of the consist, but in Rio they're at the back of the consist pushing. And in Rio, for efficiency reasons, those Bankers disconnect from the train while the train's moving. They disconnect, stop, and return back to the mine to bank out another train. It was very complex, functionally very complex piece of work as you can imagine, for the system to do that autonomously, and complex to do the RAMs and assurance work for that. And we had involved discussions with the ISA at the time. Arvin and I were reminiscing on that a little, and I was, laughing about the challenges that we had faced. But in retrospect, it's enjoyable to look back on that. That's one highlight, I guess. Along with the order hall system in general, but also, of course, as I've often said to people, the work that we did for Roy Hill, that people often forget, that we developed for Roy Hill, a very beautiful, I would say, system, technically beautiful system that I'm very proud of. So that's also something else that I'm proud of that we delivered.
Amazing projects. That Banker you just spoke about, that's a driverless, right?
Yeah, the Banker system, originally we designed it to be completely driverless, but there were issues for us to select a technology to detect the detachment of the Banker from the consist, from the main train. And so in the end, we had to limit the system to a driver supervised system where the driver, their only role is to confirm the separation of the Banker. Apart from that, it's fully driverless.
Great. Even that Royal project, I think that in the initial VBTO stage, I was involved, and I was really surprised because I come from a conventional signaling and standing on the forefoot, and you see nothing at all on the railway.
That's right. That's right. Yeah, it's really, well, we won awards for that, of course, as you well know, or I should say Roy Hill won awards for that, as you well know. So I think it was widely recognised at the time for the technical achievements.
Great achievement. Hats off. Not an easy task, especially when it comes to deliver innovative projects like this within the tight budget. So going back to our previous discussions where we touched about leadership, because I'm still stuck there, even though we talk about technology and innovation, what do you think makes a great leader, Andrew?
Yeah, that's a topic that I'm quite interested in. So for me, the leader isn't the guy who stands at the front and directs the team what to do. As you heard from what I said before about how I run my day, that the leader is the guy who gathers information from the team, that facilitates the working of the team. For me, the leader is the person who's painting the big picture, defining the morals or ethics of the team, giving the broad objectives for the team. But it's the team themselves who need to decide or determine how they're going to achieve those objectives. So the leader for me is a person who is there to facilitate, motivate the team to achieve those objectives. I gave an analogy when we were discussing this previously about the leader being the guy who's steering the boat, but the crew are the people who keep the boat running on the course that's being set by the leader. So that's, for me, the key thing to remember as a leader.
Absolutely. There is nothing I would disagree with. And thanks for bringing these leadership skills into the industry, Andrew. Inspiring the next generation of engineers. What Hitachi doing in the space of innovation and research, please?
Yeah, so Hitachi are active on multiple fronts. We're active, of course, developing signaling technologies for a long time now. As we just discussed with the Roy Hill project, we developed the technology to enable the signaling to be fully centralized without the need for trackside infrastructure like Belize. So the Roy Hill system has virtual Belize rather than actual physical Belize. But, in addition to this and since that time, Roy Hill now has been in operation for several years. We've also been working on new solutions for we're continuously improving, of course, our solutions for the ETCS and CBTC, but also working on new solutions for trackside worker protection. As an example, one of the new products that Hitachi is working on, which synchronizes well with some of the concerns, I think, globally, but also from the perspective of the ONSA, that we need to enhance and better protect the processes for our trackside workers.
Agreed. And even more, I hear a lot about your company, that Hitachi Rail, working on a new or improved product or processes whose technological characteristics are significantly different from before. So what do you think makes a successful engineer? Is this the reason?
Yeah, so for me, it might depend on what area of engineering you're working in, but for me, working in systems engineering and in particular in RAMs, one of the key attributes of the successful engineer is persistence. That you have to be persistent because you need to be persistent in gathering the information that you need and processing that information. I guess a few properties that I would say list off would be persistence, thirst for knowledge, patience to learn, and having a keen eye to observe. So, but most of all, I think, as I said, the most important property, I think, is persistence and patience. And as I've said before, that in particular, the RAMs engineer needs to be the guy who doesn't forget. So you need to come back to the problems and make sure that the problems have been dealt with, because that's what assurance is about closing out all of the issues in an appropriate way before the system's released.
Agree. What an answer. I like those words: persistence, thirst for knowledge, patience. I think not just for an engineer, but in every other field. I think what you just said applies. And
quite possibly. Yeah.
And you did as well raised ramps. You brought into the picture ramps. And my next question was about that. How does one become a ramps expert? Because not many people know about ramps, even within the rail industry.
That's a question actually that from time to time people ask me, is about how they can become, maybe they don't always use the term expert, but they want to know how they can, become knowledgeable in the area of RAMs. And it's not a quick or easy path. There's a big body of knowledge, just like any specialized area of engineering, I suppose. There's a big body of knowledge that needs to be mastered. But on top of that, I think that it's not just a matter of entering into the RAMs space and learning everything to know about RAMs, but the really good RAMs engineers have also got a grounding in the engineering or in the systems engineering or even more particularly in the, electrical and software and validation. So, and really the more broader your experience, then probably the better. So you typically see often that the really good RAMs guys, just as probably the same as validation, are often guys that are a bit older that have I use the term guy there, meaning non-gender specific, by the way, just to be clear, a bit older and have experience across quite a wide range of the life of the system life cycle. So, this is, I think, the path to be the expert. And so that means that you need to be patient and take the time. It's not going to be a quick process.
So when we talk about RAMs, I hear a lot about MTBF, MTTR terms, and using the software for RAMs calculation. How much value does it add in RAMs?
So a lot of people using tools the things you just mentioned are more related to the availability, and definitely tool-based approaches are essential, I think, to make the availability or reliability calculations. It's really essential to use tools. It's possible to make calculations on paper or with Excel, but really time consuming. For sure, most people are using tools now to do that, like Reliability Workbench or Windchill and so forth. But even in the safety space, tools are a benefit to organize your analyses, like a FAMICAs, for example. Or, for example, in Hitachi, we're also using the DOORS tool, to store our hazard logs, for example, as well as our requirements, so we can have an integrated approach to requirements and hazard log management. So definitely tools are a big benefit to the RAMs engineer. You can do the job without them, but increasingly using tools to speed up our work.
The only reason I brought this up because when you go for a product type approval, they ask that your MTBF or your MTTR should be 99.9%.
Yeah,
that's where right. I get that way. How can you do that? So
we do those calculations for the availability, but also for the safety. Another, the other side of the coin is the safety and the tolerable hazard rate, as it's called. And the calculations, you can make the same sort of calculations. Typically, though, people use fault trees for calculating THR rather than RBDs. Typically using RBDs in availability and fault trees in safety, but these are really two effectively semantically equivalent, notations, syntactically different, but semantically equivalent. Yeah. So, but it's essential. You bring us into other topics like the risk acceptance principles but in some cases you need to make those detailed calculations to convince people.
Brilliant. Are there any specific professional bodies where we can learn more about RAMs and any websites?
Yeah, there's, I think, at least two in Australia that are specific to RAMs, in addition to the more broader engineering bodies like the IRSE, for example, the Institute of Railway Signalling Engineers. But in the safety space specifically, there's the Australian Safety Critical System Association, which runs a conference yearly. And there's also the Rail Industry System Safety Board, which is the RISB, which also runs several conferences each year. One of them, I think at least one of those very specific to safety. So I would, those two organizations, in particular RISB has a great resource, but unfortunately to really make use of RISB's website, you need to be a member. That's the only problem. If you don't have that, then I would say to head to the ONSA's website, the Office of the National Rail Safety Regulator, and in there you can find for free lots of resources and guidance. Those are a few places you could look.
Thank you for sharing that valuable information, Andrew. Now, moving ahead, what do you think the future holds for rail and transportation in general?
Yeah, this is an interesting topic. I think increasingly getting talked about. At a conference I was presenting at a few weeks ago under the auspices of the IET, they were talking about, as many of us are talking now, about mobility as a service. And I think that the future for rail is linked to this buzzword, mobility as a service, so that in the future we'll see this more integrated model of transportation, most likely, I think, associated with the move towards driverless vehicles. As we move towards autonomous vehicles, that will hook into this mobility as a service, so that we see, rather than people driving their own cars, they'll be jumping into autonomous vehicles that are cruising around and taking them to, if, possibly is taking them end to end to the destination, but also maybe for a longer journey is taking them to a railway station where they'll still catch a train for a longer journey for cost reasons. So I think rail will still be there, part of that overall cost and environmental aspect.
Yeah, amazing. I would look forward to it. And probably that would help with less or no carbon emissions at all.
Absolutely. I think it's critical for various reasons. I'm sure I was mentioning to some of the colleagues in Brisbane when I was there earlier this week that I'm sure the big car companies don't like this innovation, because I guess you won't sell as many cars when they're being shared in this smart way. But, less cars we can manufacture and less cars we have rolling around the streets, the less carbon we have. So, and the more we can get people, therefore, to use trains, because with mobility as a service, you're going to have an end-to-end journey. At the moment, you might have these unsatisfactory wait times, but in this dynamic where you've got enough of these autonomous vehicles floating around, you won't experience that. You'll just get into a car, go to the train station, train will be there. At the other end, you'll pick up another car, go to your end destination, and it will be seamless.
Wow, that's glaring. And Andrew, I came to my last question to you. What would be your advice to young people getting into engineering?
Yeah, I would say that my advice for young people getting into engineering is to probably two things, at least two things. One is to take the time to build a strong foundation. It's the same point I raised a little earlier in our chat about if you want to be a RAMS engineer, take the time to first learn about systems or software or even the technologies themselves, but even before you try to learn about RAMS. That's one thing, is to get the foundations in place and be patient to learn. The other thing is to take on the difficult work. Don't shy away from the difficult project or the as I would express it, the dangerous mission. Take on the most challenging things you can and challenge yourself. Take yourself out of your comfort zone and do things that you're not sure that you can do or achieve. These are the two pieces of advice, main advice I would have for the young guys.
Is there any graduate program in Hitachi Rail if younger people would like to join Hitachi?
Yeah, in the past, we have had a focus on graduates. We're focusing again on the bringing graduates into the organization because we recognize the value of bringing in new engineers who we can train specifically in the ways that we work. It's a value to us, and it's a value to the new engineers that we're able to train. Those young people, I think, are an important resource for the future that we have to foster.
Apart from engineers, is there any scope for TEF candidates like Cert 4s in signal electricians, people who do electricians Cert 4 courses?
I think it depends on the role. Certainly, generally though, we do tend to favour degree qualified people. So normally to come into an engineer role, you have to have a degree qualification. That's the way that our competency system works. It's not necessarily a blocking point for performing a lot of the work that we perform, particularly in the testing and commissioning and validation space, where the most important thing sometimes is the technical competence against a particular specific technology. So there's definitely space even for those non-degree qualified people to have a role in our organization.
Beautiful. Thank you. Thank you, Andrew. Thank you for spending your time, agreeing to spend your valuable time with us. And probably I might call you again in future to discuss more in detail about RAMs and assurance.
That would be very interesting, Sheikh, and I welcome any future conversations.
Thank you.
Thanks, Sheikh.
I believe everyone listening to this podcast has got something to take away from today's discussion. If you like this podcast, please listen, follow, and share this podcast within your network. If you believe we should be sharing your story or someone within your network, there is a railway leader who should be here sharing his or her contribution to this industry, contact me on railwaytransportationsystems@gmail.com. Thank you for your time today. See you next fortnight. Until then, stay safe and take care of yourself.